Hello and welcome again to Crash Course AP Physics 1. In the previous video, we learned about the conservation of momentum, and in this video, we are going to learn about elastic and inelastic collision. So let's get started. In elastic collision, the kinetic energy is conserved or there is no loss in the kinetic energy. We call it as elastic collision. Whereas in inelastic collision, there is a loss in the kinetic energy when the collision happens, and this lost kinetic energy is converted into thermal energy, sound energy, or the material deformation. Let's understand from this example. So in elastic collision, when the ball is thrown with some height h, its potential energy gets converted to kinetic energy. When the ball collides with the surface or with the ground, then there is no loss in the kinetic energy, and thus it rebounds back with the same kinetic energy. Thus, it is able to achieve the same height. Whereas, in this example, a basketball, when thrown with height h, so at this point, the kinetic energy, when it hit with the surface, some of the energy will be lost. So, this kinetic energy would be, or the final kinetic energy would be less than the initial kinetic energy. So the height achieved in this is less than the initial height. Another example, completely inelastic collision. When the ball is inflated, it is thrown with some height, it doesn't rebound back at all. So all the kinetic energy would be wasted in the collision with the surface. Let's understand the difference between elastic and inelastic collision. Kinetic energy would be conserved, and in inelastic collision, kinetic energy is not conserved. That is the major difference between elastic and inelastic collision. Momentum is conserved in both the cases. Energy conversion, no conversion, because the energy is not wasted, so the energy is not converted. This is the ideal case. In inelastic collision, when the energy is lost, it converted in the form of heat or sound or to some other form. In elastic collision, objects after the impact, they separate, they don't stick together. Whereas in inelastic collision happen, it sometimes it sticks together. It may stick together. Some of the examples like perfectly elastic collisions are rare in real world. Example, collision or in atom and nuclear scattering. And in inelastic collision, most of the real world collision like car crash collision in sports, these are the example of inelastic collision. Let's solve some of the problem. Block A of mass 2 kg is released from this top. So this is 2 kg. 3.6 meter long plane inclined at angle 30 as shown in the figure. After sliding on the horizontal surface, block A hits and sticks to block B, which is at rest and has the mass of 3 kg. Assume friction is negligible. The speed of the block after the collision is nearly. A is sticking with B, so they would get the common velocity as Vf. So we have to find the velocity. So at this point, this h, due to this height, A would have the potential energy at this point, and the initial velocity is 0. So that's why kinetic energy is 0. So at this point, the potential energy is there, and when block A reaches to the bottom, it would have kinetic energy because it would achieve some of the velocity at this point. So with the help of energy conservation, I can write that the potential energy would be converted to kinetic energy, or I can write mgh is equal to half mv square. M got cancelled. So I can write it as 10 into height, I can write as 3.6 sine 30 degree is equal to into 2 is the velocity square. So when I solve it, the velocity would be equal to 6 meter per second. So this is A having the velocity of 6 meter per second, and this is B. Before the collision, it was stationary, so the velocity is 0. After the collision, this A block and B blocks stick together and moving with Vf velocity. So I can write momentum before the collision is equal to mass is 2 kg into velocity is 6 plus momentum of B is 0, and momentum after the collision is equal to total mass of the body 2 plus 3 is 5 and moving with Vf velocity. So there is no force, external force acting on the body. I can write that momentum before is equal to momentum after. Conservation of momentum. So momentum, it is 12 and 5 into Vf. Vf is equal to 12 upon 5, which is 2.4 meter per second. A is the correct option. Two identical objects A and B of mass capital M move in one dimension horizontal air track. Object B initially moved to right with velocity v0. Object A initially moved to the right with the velocity 3v0 so that it collides with object B. Friction is negligible. Express your answer in mass and velocity. Determine the total momentum of the system of two objects. So the total momentum of these two objects is equal to momentum of object 1 plus momentum of object 2. So it would be mass into 3v0 plus mass into v0. So I can write 4mv0. This is the total momentum of the system. Our students predict that the collision would be totally inelastic. Inelastic means the objects stick together on collision. Assume this is true. Determine the following for the two objects immediately after the collision. So we have to find the speed and the direction of motion. So when they stick together after the collision, this is m and this is m, it would move with the common velocity vf. So I can write momentum after the collision, it is equal to 2m into Vf. So from the conservation of momentum, I can write momentum before from equation 1, which is 4mv0 is equal to momentum after into Vf, 2mvf. So mm got cancelled, it is 2. So Vf, the final velocity, is twice of v0. And the direction, because this is positive direction, this direction which is positive, so this is the direction of the velocity. So the direction is towards the right. The two blocks of masses m and capital M and 2m shown above initially travels at the same speed v but in opposite direction. They collide and stick together. How much mechanical energy is lost to other forms of energy during the collision? This is negative direction and this is positive direction. So momentum initially is equal to mass into velocity minus 2m into velocity. So it would be minus mv. And after the collision, these two get stick together. So it is m plus 2m. And moving, let's say it is moving with vf velocity in this direction. So it would be momentum after would be 3m into Vf. So let's just equate these two. So it would be momentum initial is equal to momentum after or final momentum. It would be minus mv is equal to 3m into Vf. M got cancelled. In this case, Vf is equal to minus v by 3. So minus indicating that the velocity is in the negative direction. So the direction which I assumed is incorrect and the direction of the velocity after the collision is in this direction, which is v by 3. So now we have to find the energy. So initial kinetic energy of this system is equal to half mass into velocity square plus for the second block half 2m mass into v square, and final kinetic energy is equal to half mass is 3m into velocity which is common vf square. When you solve this, it would be 3mv square upon 2, and just equate the value of vf, which is v by 3 square of it. So it would be 1 upon 6 mv square. So lost kinetic energy or lost energy would be equal to initial kinetic energy minus final kinetic energy. So it would be 3 upon 2 minus 1 upon 6, and mv square, take it as common. So it would be 8 upon 6 mv square, or I can write it as 4 upon 3 mv square. So this is the lost energy or lost mechanical energy. Since all this is happening at the same level, So the potential energy would be same for all the cases. Lost mechanical energy is equal to 4 by 3 mv square, which is C is the correct option. That's all from my side. If you want any tuition help from me, then you can scan this or email me at forcetra.physics@gmail.com. See you with the next unit.